Hello, hi. So we've got a window up. That's cool. Now let's get to the job of actually drawing a triangle. Now, I realized that I started a project and I called it stage 1. However, if we were to break this project into separate stages, we would have to reconfigure the whole project each time with the dependencies. That's a bit much. So let's just keep modifying the original stage. And I am keeping track of this code. So if you go down to the downloads, I've linked the stage of the code at every point with some descriptive comments as well. Okay, so we'll go and we'll open up the project that we had before and just make this text a little bigger. Okay, that's not bad. All right, so the first thing I'm going to do is I'm going to refactor this a little bit. So all of this big chunk of code up here is, we can put that out into another function. So we'll just, whoops, just cut paste all of this. Okay, so we're going to call this initialize. It's not going to take any, oh, actually, let's pass in window height and width. Okay, that's all the stuff we had before. And for the return type, well, this function, part of it is creating a window, so let's return that window, or rather, return the pointer to the window. Okay, that's looking good. Now we have an issue. Okay, so once we create everything, then we will return the window. Great, but then we have an issue here, right? So we're returning -1, but that's an integer. So perhaps for our error code, we'll return null. And I'm just going to get rid of this line here, the terminate, because we'll do that down here. So let's go. So what we'll do is we'll call the initialize function, and that will return the window, and then we'll say if we got null, in other words, if that is not a valid pointer, then we'll terminate at that point and return -1 as the error code from the main function. Okay, cool. So that all seems not bad, but we do need to put in a width and height. So we're going 640 by 480. Awesome, we'll just pass that in here. Okay, that's good. And then we'll just modify this code in here so it's a little bit more dynamic. So we'll go width. Oy, that's not good. And height. Okay. As far as I can see, that looks okay. Now let's just quickly double check it by running. And it works. Awesome. Cool. Okay, so the we're going to be making a triangle. I'm going to split this into 2 stages. First stage is we're going to need to create shaders. And then the second stage is we will create all the data structures which are needed to pass information into OpenGL and get the triangle going. Okay, so back in the old days, we almost did not need to create any shaders. However, with modern OpenGL, we always need to create at least two shaders. We have a Vertex Shader and a Fragment Shader. What a Vertex Shader does is it takes information about the points, the corners of a shape, and it might do some transformations. For instance, if we want to make this a three-dimensional triangle, then we'll need to do perspective and view transformations on the points. Then it passes them along the graphics pipeline, and it comes to a rasterizer, which takes that per corner information. So for our example, we'll be having, for every corner, we'll define a position as well as a color. The rasterizer takes that information as well as the type of shape that we're drawing. For our case, we'll be drawing a triangle, and it will break that information up into little pieces called fragments, they're really pixels, and send the fragments to a fragment shader. So again, the Vertex Shader does the transformations, and then the Fragment Shader does some other calculations to work out which color to make the pixel, the fragment, basically. Okay, so let's break this down one step at a time. The first thing we will need is we will need source code. Now, at the heart of it, source code is just a string. So we can literally just type this in right now. Let's start with this. We'll say okay, so this is the first line of our shader code. It's a string. If I want to continue as a multi-line string, I just put a new line tab, a new line character here, and jump on to the next line. C++ understands that just fine. And I will explain this in a second. Okay, so there we have it. There's a second line of code. Now, just note that I guess technically we may not need this const, but it's a good idea just for safety. But to define a string, C++ style of string is just standard string, std string. The C standard is a character pointer, because what is a string? Ultimately, a string is a list of characters, a list of letters. And the way we define a list is as a pointer. Okay, so a list is really just a pointer to the first element of the list. Okay, so I'll do a bit more work. I'll type more of this out, and then I'll start to explain the actual code. Okay. Okay, cool. So just going through here. So to start with, we state that we are using OpenGL version 4.5, and we're using it in core mode, not legacy, not immediate, not compatibility, core mode. Okay, then we define what's called attributes or bits of information. We have some in attributes and an out attribute. The attributes we're taking in are a three-dimensional vector like x, y, z called position, vertex position, and a three-dimensional vector like red, green, blue called vertex color. Okay, then we are outputting a three-dimensional vector called fragment color. Okay, so let's get to the actual function. So this has a return type of void. It's the main function. Strange, I don't know what's going on with that auto tab there, but here is the code. So we're not doing much. The only thing to note is this GL position is kind of a global variable. So whereas we took in the color and sent it directly on its way to the fragment shader, for the vertex shader, we, with the color, for the position, we, instead of passing that along to the fragment shader, we pass that to GL position, because essentially the fragment shader will not know anything about the position unless we explicitly pass that in. That's not necessary. Position is used by the rasterizer, which is not something that we have access to. That works behind the scenes. Okay, so also this /o is what's called the null character. And that's one L, not two L's. So null with two L's is a pointer, null pointer. Null with one L is the null character. Okay, that is just indicating that the string has finished. Okay, so we've got that. Now let's go ahead and create the fragment shader code. Okay, so let's go with this. So version 450 core, that is good. Now we can get rid of these. Layout location 0, and this is now taking in this thing. So this fragment color comes out of the vertex shader and into the fragment shader. This is kind of why we call it a graphics pipe, because things flow along. Okay, so yep, there's one more thing that we need, and that is we need an output. Okay, cool. Yeah, so this is a, I should have explained this before. Sorry. So with position, we have x, y, z, that's a three-dimensional vector, but there is a fourth component called w, and that is used for perspective stuff to track how close something is to the camera. So what we do if we want to make no transformation is we just stick on a 1.0 on the end. Okay, now in this case we have red, green, blue, so a three-dimensional vector, but we are outputting a four-dimensional vector because the fourth component is the alpha. So just like we added a 1 on the end for position, we'll add a 1 on the end for, as a matter of fact, let's do this. So we'll take fragment color, stick 1 on the end, that passes through the fragment color with an alpha of 1, and that will be the final color. And that's it. So very simple. We are making no transformation to the color. We're just passing in the color that we get. Awesome. Okay, so now we need to compile the shaders. Okay, so I'm going to kind of do this at the same time. So when we call GL create shader, in the background, OpenGL creates its own like memory location to hold a shader program and allocates that and gives us back a number. So let's say we run this and Vertex Shader gets a number of 5. That means it is the index 5 shader within OpenGL's memory context. Okay, so let's keep going here. We'll get the Fragment Shader, GL Fragment Shader. Okay, and now what we'll need to do is we'll need to pass in the source code. So we call GL shader source. What do we need? We need a shader, so in this case Vertex Shader. We need count, we are passing in 1 bit of source code, and we need a constant string, so that will be the Vertex Shader source, and then the length. So if we pass in null, that is telling, yep, it needs a, if we look down here, it says, where does it say this? So let me just, okay, so look at the thing again. Now it says, it wants, this is a little hard to see, wants a GL character pointer to a constant pointer string. So this is a little strange as far as signatures go, but they want a pointer to the location of Vertex Shader source. So what we do to get around that is we put this AND symbol, and that takes the memory location of this variable. So this is the first time I've introduced this here, so I'll write this again. That's not that, it's okay. So we pass in the, the memory address of where that shader source is stored. Okay, so we'll grab this again, put it down here. This is for the fragment shader, and of course we'll need the fragment shader source. Okay, awesome. So that's it. We have passed in those strings to the data structure. It's ready to go, except we then need to compile. Okay, so we compile that one, and we compile our fragment shader. Awesome. What if it's not so awesome? What if I made a typo? What if I defined a variable and it just wasn't working? We need to put a bit of code in here to spit out error messages if we have an error. So the way we do that is we'll make a variable called success. And we will make just a standard memory bin, which can store 1024 characters. Okay, that will go. Okay, so we'll do the same thing down here. So we're just querying, was this successful? If it was successful, then we'll get a non-zero result. If it is successful, we'll get a 0 result. And so what we can do is we can say if not success, then print out an error message. Cool. Okay, so we call this function getShaderInfoLog to query the error message which occurred. So when error messages occur, they kind of get stacked up in a queue. We just query that to get the current error message, and then we print that out to the console. So we can just copy and paste that again. And just run it on the Fragment Shader. Okay, awesome, cool. So we've got those going. We've got these Fragment Shader and Vertex Shader compiled. What we need to then do is link them together to make a proper shader, or in OpenGL, it's called a program. So I'm going to confuse things a little bit by making a program and then calling it a shader. In practice, these are a little bit used a little bit interchangeably. So now we'll go ahead and create our program. Okay, so remember these modules were already compiled, so they're all good. They're in machine code. They're good to go. We just need to link them together. The next thing we want to do is we want to get any possible error codes which may have occurred. So this is actually pretty similar. And something I forgot to mention is here when I write GL get shader IV, I mean GL get shader integer value. Let's go through here. So we are now getting an integer value from the program. And we're not compiling, we're linking. Right, and then it's get program info log. Okay, cool. So hopefully this works. Okay, so now we've got this, but we need to, well, we should probably delete those shaders. So remember, we have the shader code, which is in strings, and then we take that and bounce it into a shader module, and then we compile that, and then we link it together. But once we've linked it together, it exists just fine within our fully done program. So we can then just delete it. That's perfectly fine. Our program has the compiled and linked code. It is all good. Okay, so what I found, 9 out of 10 times, if we have a really bad, unexplainable error, what we need to do is make sure we're using the correct shader or the correct program. So what we do is after we've got this all good to go, we say GL use program. And as we get more complicated programs, we'll be using a whole lot of these, and we need to pay attention to the program that we're using. Anyway, so what this has done is we've got this set up, but we have allocated some memory for the program. So right at the end, we should probably free that memory up. So we go GL delete program, and it says it just takes a program. So we'll pass in our shader. Okay. Now the last thing we want to do is, see, we've typed a bunch of code and it's kind of made our main function a bit big. So let's take all of this and abstract it out into its own function. If this wants to work with me. Yep. Yep, that's fine. Okay, so cut, paste. Okay, so what do we want? We want to do that. And so this function is basically creating the shader, but we need to return the shader as well. So a shader is created on the graphics card, referenced by an unsigned integer. So I think this is pretty much fine. We're just going to return shader. And then the usage is down here. We'll say there. Okay, cool. So let's try to run this. Cool, cool. Looks just fine. Now let's try to test our error handling. So I got rid of this this semicolon here. This is bad. Good. Now if we look at the output here, it says syntax error, unexpected brace, expecting these things. So that's perfectly fine. We have that, and just to be sure, let's see what happens. Okay, so we've attached everything. What happens if we delete a shader before we link it? Nothing. Oh, sad face. Okay, what happens if we delete a shader before we attach it? Nothing. Oh, never mind. Never mind. It's fine. I was trying to trigger a linking error. Maybe we would have trouble if we were trying to actually use this for real, but that's fine. Okay, so that's it for now. We've got a shader going, basically. In future, we will write a like a file reading program, which will just read this in from an external file. That's a much better way to do it, but we're just going to take it one step at a time, start with something that works, and take it from there. All right, cool. See you in the next one.